Hello, ladies and gentlemen. We are talking about understanding functions in Notes 8.1. So if you could turn to page 2, that would be great. And if you can follow along and see what's going on with our lesson here, that would be wonderful. All right, so in order to know what a function is, we have to define what a function is. So I'm about to show you the definition. Please make sure you get it all written down before we move on. All right, so the definition of a function is a relation in which each input or x value, so our inputs are always going to be our x values, has only one output or y value, okay? So let's take a look at what we have in question number 1. Determine whether each relation is a function. Explain your answers. So let's take a look and see what we have here. If you look right here, our inputs are our x values, right? So 2, 3, 5, -1, and 4 are all inputs. And our outputs are our y values. So those are our outputs right here, 3, 0, 2, -2, and 1. So our input of 2 has one output of 3. Are there any other inputs of 2 that have different outputs? No. You see this 2 right here, however, this 2 is an output, so it's not the same thing as this 2 right here, okay? So each input for the input of 2 has only one output. The input of 3, its only output is 0. The input of 5 has only an output of 2. The input of -1 has only an output of -2. And the input of 4 has only an output of 1. There are no inputs that have more than one output. So what we're going to do is we are going to say, yes, this is a function. Because each input has only one output. Okay? All right, so let's take a look at question number 2. In question number 2, we have something called a mapping. And a mapping will just show you what each input is mapped onto. So here, our inputs are our x values, right? And our outputs are our y values, okay? So these right here are our outputs. So our input of 3 has an output of 0. Our input of 4 has an output of -6. Our input of -3 has an output of 10. And our input of -8 also has an output of 10. Now, let's look back at our definition carefully. It says it's a relation in which each input or each x value has only one output or one y value. So if we look at our mapping right here, 3 has only one output. 4 has only one output. -3 has only one output, and -8 has only one output. It happens to be that the -3 and the -8 share the output of 10. However, it doesn't say anything about what the outputs are allowed to do. Outputs can do whatever they want in order to be a function, but inputs can only have one output. So each one of these inputs does only have one output. So again, we're going to say yes, it's a function because each input has only one output. Again, the outputs, it doesn't really matter how many inputs are matched from an output to an input, okay? So please try number 3. See what you think. Pause the video, make your decision, and then come back to me to see how you did. All right, so for number 3, if you look right here, this input of 2 has an output of 5. However, this input of 2 also has an output of 1, which means that each input does not have an output. Once we find one example where an input has more than one output, it is no longer a function. So here we're going to say no, it is not a function because there is an input that has more than one output. All right. So now, if I were to draw a graph of what these points look like right here, I'm just going to do a really quick rough sketch. So here's my x-axis, here's my y-axis, all right? And if I were to graph out where 2, 5 is, it would be 2 to the right and up 5, so it'd be approximately right here, okay? So I'll put a dot right here to represent 2, 5. And if I were to represent 3, 7, it would be to the right 3 and up 7, so it'd be a little bit higher. And then if I were to graph out 2, 1, it is right here, okay? And then 4, 8 is going to be even higher and more to the right. Now, if you notice, the 2, 5 and the 2, 1 are the two coordinates that give us a hard time, and if you connect them, they make a vertical line. So another way to test to see if something is a function is by doing something called the vertical line test. So the vertical line test just basically says that if you have some type of a function, it's only a function if you can draw any line through it, any vertical line through it, and each line will only cross through one point. So there's an example right there. If we had a linear function, a line function right here, these are the functions that we've really been focusing on a lot this school year. Every single vertical line I draw through my linear function will only cross through once, so I can definitely say that it is a function. And that is true of every single type of line except for one, which we will discuss in class, but maybe you can see if you can figure out which one won't work, okay? Now, another example of something that may not be a function would be like a circle. If I were to take a circle and draw a straight line through it, it crosses in two places. So this is not a function because each input, each x value right here, has more than one output. It has two different y values. So we're going to write down the blanks for what we need for a vertical line test. If any vertical line passes through no more than 1 point, so 1 point is the maximum number of points it can cross through, of the graph of a relation, then the relation is definitely a function. Okay, so let's take a look at what we have right here in question number 4. In question number 4, if I draw a vertical line through, it intersects more than once, which means that it is a no-go. It does not work, okay? Even though if I graph out a line right here, it only technically crosses through once. However, if you have just one line that crosses through more than once, one vertical line, then it automatically disqualifies it from being a function. So here we're going to say for number 4, we're going to say no, it's not a function because it fails the vertical line test. And we'll use the abbreviation VLT to stand for the vertical line test. I want you to try questions 5 and 6 and then come back to me when you're ready to go. We'll see how you did. All right, in number 5, if I were to draw any vertical line through my relation right here, every single vertical line will only intersect once. Now, a lot of people will think it intersects twice because they think it intersects here. However, that's not an intersection point because this right here is just the x-axis. It's not the actual function. This right here is what is the function, and this will only intersect one time for each vertical line. Therefore, it is a function, so we're going to say, yes, it is a function because it passes the vertical line test. Sorry, 1 second. Let's get back to where we were. So yes, it's a function because it passes the vertical line test. All right, let's see how you guys did on question number 5, or excuse me, question number 6, I believe is what we're looking at right here. So if I were to look at this right here, this only crosses through the function at 1 point. However, I have at least one line that will cross through my function more than once, so it automatically is not a function. So what we're going to say here is, again, no, it's not a function because it does not pass the vertical line test. Or we could say it fails the vertical line test. Okay? All right, so let's take a look at number 7. It says the high jumpers at a track meet are wearing numbers on their uniforms. Each of the 5 high jumpers on the team made one jump. The height cleared by each athlete is shown in the table. So question A says to use a mapping diagram to represent the relation between the numbers of the athletes and the heights that they cleared. So first thing we need to do is discuss what our inputs are going to be and what our outputs are. So our athlete numbers are going to be our inputs, and then the height that they clear, the result of doing the function, which is to jump, is the output. So the results are their heights, okay? So the inputs are who they are, the results are what they got, okay? So what we're going to do when we do a mapping is we do one oval to represent our x, or our input, okay? But in this example, our input are athlete numbers, all right? And then we do another oval to represent our y, or our output, and it's the height that they cleared, okay? So it's kind of like when we do a graph, right? We put our x-axis here and our y-axis here. Our x variables go here, our y variables go here. However, this time we're going to put all of our x variables in this oval and all of our y values in this oval right here. So all of our x values are given to us right here. 1, 2, 3, 4, 5. So I'm going to fill in 1, 2, 3, 4, 5. Now this needs to go in numerical order, so you must go from the smallest number to the largest number, okay? And then these values are our outputs, and again, we're going to go from the smallest number to the largest number. So our smallest number is 139, and then after that we've got 143, all right? Then we've got 145, and then we've got 151. Now we're only going to write 151 once, even though you see it twice, because there's no need to repeat our values. So I want you guys to write yourselves a note that it needs to go in numerical order from least to greatest, and that there are no repeats when we're doing a mapping, okay? Because if we don't show our show our repeats, we can't tell if it's a function or not. And then all we have to do now is just draw arrows to match everybody up with what they got. So athlete number 1 had a height of 145, so I'm going to draw an arrow from 1 to 145. Athlete 2 got a height of 143, so that's what that arrow looks like. All right. Athlete 3 will go to 139. Athlete 4 will go to 151, and athlete 5 will also go to 151. Now we want to know, is this a function or not? Well, let's look at all of our inputs. Do any inputs have more than one output? No, each input only has one output, so we're going to say that this is a function because each input has only one output. Okay, so this is a function because each input has only one output. All right, so question C says, suppose the inputs are the heights cleared by the athletes and the outputs are the athletes' numbers. Use a mapping diagram to represent this relation. Is this relation a function? So this time it's saying that we're going to flip it. So this time our inputs are our heights. So we're going to say 139, 143, 145, and 151. Okay, so these are our heights cleared. Okay, and then afterwards we've got our outputs are the opposite, and they are 1, 2, 3, 4, 5, okay? So the height of 139 gets matched to 3. All right, so we're going to draw an arrow from 139 to 3. The height of 143 gets matched to 2. The height of 145 gets matched to 1. And the height of 151 gets matched to 4 and 5. So this time, when it's done this way, and I apologize, we need to write our athlete number right here. I forgot to label. This time, each input does not have one output. We have an input that has more than one output, and that's this 151. So we're going to say this is not a function when we do it the opposite way, because there is an input that has more than one output. All right? All right, let's take a look at number 8. Number 8 is review of what we've done before, but let's just refresh our memories on how to do these types of problems. This is a little bit of a simpler one. We will do some more complicated ones in class, but please make sure you understand these. So a tank contains 8 gallons of water. Water is then pumped into the tank at a rate of 2 gallons per minute. The total amount of water in the tank, y gallons, is a function of the number of minutes x that water has been pumped into the tank. So it says that it's at a rate of 2 gallons per minute, which means that we have a linear function because the rate of change or the slope is always the same. So write an algebraic equation for this function. So the number of gallons, which is y, okay? So we're going to say the number of gallons, y, is equal to 2 gallons per minute, x. So we'll say 2x, plus an initial 8 gallons of water to begin with. All right, and then part B says construct a table of x and y values for the function. So here's my x value, here's my y value. We're going to give a bunch of x and y values. So when x is 0 at the beginning, when no minutes have passed, the tank already has 8 gallons of water. So we're going to say at 0 minutes there were 8 gallons of water. And then after a minute passes by, it increases at a rate of 2 gallons per minute. So after a minute passes by, there's 10 gallons. After 2 minutes pass by, there's 12 gallons, so on and so forth. All right, so we can establish a pattern. And then it says use the table of values to plot a graph to represent the function. So first thing we got to do is make a title, okay? So we are going to say gallons of water versus time. All right, and I'm going to say H2O, just to make things a little bit easier. So our independent variable is time, and it's measured in minutes. All right, and our dependent variable right here is gallons of water, or water. We can just say water, or amount of water, and it's measured in gallons. All right, and I'm just going to go by ones for time. So this is 1, 2, 3, all the way up. And then I'm going to go by twos for gallons of water. So we've got 2, 4, 6, 8, 10, all the way up. And we know that at the beginning, when no time has passed by, 8 gallons of water are already in the tank. And then after 1 minute, you increase by 2 gallons. All right, so it's going up by 2 gallons every minute. So here's my linear function right here. And it is a function because each input has only one output, right? And just one quick thing that I just want to mention right here is, again, if you look at the slope, remember we always do rise over run. It goes up by 2 gallons, and it goes, that's the rise, and the run is 1 minute. So the slope is 2 gallons per minute right here, and the y-intercept is 8 because it starts at 8, and that's how we got this equation in this table. It's all connected, all right?